Hello, welcome to our channel for rprogramming. In this video, we will talk about assessing normality assumption for linear regression in R. So we know in linear regression, the normality assumption is very important. It says that if the dependent variable is normally distributed for a fixed set of predictor variables, then the residual is the difference between the observed y value and the fitted y value. So the residual value should be normally distributed with a mean of 0. So if you look at this figure, this is a simple linear regression because there is only one variable for independent variable here. So this is the fitted line, or say the predicted line. And actually, the observed value of y may not lie on this line. So they can on or off this line. So the difference of these two are the residuals. So overall, the residuals can be positive or negative. And their mean is 0 and the residuals normally distributed as a bell-shaped normal curve, asymmetric distributed with mean 0. So if this assumption is not met, then the regression model is not appropriate. And actually, the estimation of the coefficient and the confidence interval or the hypothesis testing of the coefficient parameter based on the normality assumption. So in R, if you want to check for the normality assumption, we can use qqPlot function from car package. And this is better than the plot function from the RBase package. And this plot will plot the studentized residuals and against the theoretical T distribution with n minus p minus 1 degrees of freedom. So here p represents the number of regression parameters. N is the sample size. So if this figure show all the points lies very close on 45 degrees diagonal line, then this means the normality assumption is met. So next we will show how to implement this in RStudio. So first have to load library car. This library have to be installed first. Load, then we create a data frame called states. We select several variables from x77 data sets, then create a new data frame called states. So we choose states, can see it contains the information for all the American states with 5 variables: murder rate, population, illiteracy, income, and first. Then say we want to estimate a linear regression model for the data states, and murder is a dependent variable, and the population, illiteracy, income, and first are independent variable. So here we only include the first part of these 4 variables. So which means there are 5 parameters, intercept, and plus the slope for these 4 variables. We just run. So the regression has been done, and we can use qqPlot fit. This is the result of the regression, and we set a simulated true, so which will show the confidence interval, a 95% confidence interval of the line. And the labels, we set row names of the states and ID list method identity. This is for interactive method. We just use this option, and also a title. So we run. Can see here, it seems the run is not finished because it allows you to add interactive with the block, but we do not want to do this. We just click finish. So this is, then you zoom. You can see this is the qqPlot. X value is the t quantiles. This is the t distribution with n minus p minus 1 degrees of freedom. Then student-sized residuals. So these two values, if show all the points, all the residuals on a straight line, then it will be matched with the normal distribution assumption. You can see in this example, the normality assumption is quite good, unless one point is very far from the straight line, and 95% of range covered almost all the points. Thanks for watching.